Okay, we're going to do a lot of activities today on this whole concept of solving solutions of a quadratic function. And over the course of the next week, we are going to learn lots of different techniques to solve. One way to solve is not better than the other. You choose the method for solving based on what's easiest based on the form of the quadratic. Okay, we've done a really good job of laying the foundation of solving a quadratic so that you guys know that solving a quadratic means we are looking for x-intercepts, roots, or zeros. These are three different names for the same thing. Okay? All right, if you follow along in your textbook here, it says, recall that a quadratic function is a function of degree 2 because the greatest power for any of its terms is a 2, meaning we have something that looks like this, y equals x squared. Because it is second degree, that means it has to have two solutions, two zeros. This is called the fundamental theorem of algebra. Second degree, got to be two solutions. What do you think third degree has to have? 3. Fourth degree? 4. It's rocket science, right? You can represent the two solutions of a basic quadratic function as square roots of numbers. So we have to do a little side lesson on square roots. Every positive number has two square roots. What? Over here. Haven't you always learned that the square root of 16 is 4? Yep. And when you do that on your calculator, square root of 16, the calculator gives you 4. This is called the principal square root, meaning the positive square root. But by definition, why is the square root of 16 4? Because 4 times 4 equals 16. But is there another option? Negative 4 times negative 4. So when we want to include both of those, we have this new notation. And it's called plus or minus. And it's just a plus sign with a minus sign underneath. So when you see this notation, it means we want the principal square root, which is positive 4, but we also want to recognize that negative 4 would work as well. Okay? This first strategy is called solving quadratics by using square roots. And we're going to look at this worked example. To solve the equation x squared equals 9, we want to take the square root of both sides of the equation. So just like in pre-algebra, what you do to one side of an equation, you have to do to the other. And why are we taking the square root of x squared? What's our goal? What? Very good, because we want to solve for just x. We want to get rid of that square sign. Follow with me? So when we take the square root of both sides, now we need to realize that when you take the square root of 9, you really get two answers. You get positive 3 and you get negative 3. Can you tell me why does it make sense that this equation has two solutions?
Because when you multiply each one by each other, it equals 9.
Good. What did I hear over here? Because it's a second degree as well. Very good. Because it's a quadratic, we want to think it's got to have two solutions. Okay? Let's take a look at a graphical representation of this. Solving x squared equals 9 on a graph means you're looking for the points of intersection between y equals x squared and y equals 9. So here is the horizontal line y equals 9. So we are looking at the horizontal line y equals 9, and we want to know, when does x squared equal 9? Okay, so locate those points. Do you see that x squared equals 9 at positive 3 and negative 3? Okay. All right. Can you please show both algebraically and graphically how we would solve this? Okay, I just had a really good question. Somebody said, aren't the solutions to a quadratic where it hits the x-axis? What is different about this equation?
It doesn't hit the y-axis or x-axis.
It does hit the x-axis way down here. But why is the solution to this equation not the x-axis? Because it doesn't equal 0. So let's go way up here because we need to clarify something. Solutions of a quadratic is when the quadratic equals 0. We are finding the x-intercepts and the roots. That's a really good question I wanted to clarify. Okay? So looking down here, if we want to know when does x squared equal 4, what are we going to draw, Braden?
We're going to draw a line at y.
Very good. We're going to draw a horizontal line at y equals 4. And think of it this way, Gibby. This might make sense. Think of this, y equals 4, as kind of our new x-intercept. Aren't we finding the two places that that parabola hits this line? Okay, so what are the answers?
Y equals 2 or x equals 4.
Yep, at 2 and negative 2. So we have one example that hits at negative 2 and 2. We have another example that hits at negative 3 and 3. Can you guys solve this using both the graph and algebra? And talk in your groups of what you think x squared equals 6 is going to be. Can you tell me what you think, how you would show this graphically and what you think the answer might be?
So I know it's between 2 and 3
Why?
because mine's at 6 and it's between the two other horizontal lines.
Good. So he said if we put y equals 6, he noticed that it falls between here. Okay. So you were guessing it's somewhere between 2 and 3. Okay. How many other people got that concept? Okay. So let's try it algebraically. What are we going to do, Brooklyn, to solve this using algebra?
You're going to find the square root of all x. So I got x plus 2.5 multiplied by x.
Okay. Here is the exact answer. Plus or minus square root of 6. Is 6 a perfect square number? No. So to use our calculators, notice that our equal sign now turns to an approximately equal to. And you guys don't have calculators right now, but I think it was 2.449, blah, 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 blah. So we were pretty close guessing it was about 2.5. What kind of a number? What do we call a number like the square root of 6? Irrational. Very good. This is an irrational number that never ends, never repeats. And so the best we can do is say it's approximately equal to 2.449. Yes, Sam?
What do you mean by never repeats it? Like, doesn't repeat it for over 2 times? Because
It never falls into a repeating pattern.
Okay, so
Like 0.249, 249, 249. That would be a repeating pattern. Okay, good question. Okay. Turn to page, oh wait. Let's look at this one. We want to do one more. Now, when does x squared equal 0? Right here? Okay, but didn't we just say that a second degree function has to have 2 zeros?
But when you square root 0, it's 0.
Okay, so this is kind of crazy, but hypothetically, the square root of 0 is positive 0 and negative 0. So there are 2 roots. It just happens to be they are the exact same thing. You with me? Okay, turn the page. And this is the concept right in the middle of the page. It says, the quadratic function x squared has 2 solutions when y is 0. Therefore, it has 2 zeros, both positive square root of 0 and negative square root of 0. these two zeros of the function or roots of the equation are the same number. So those two roots, even though they're the same number, we call it a double root, or we say there is only one unique root. Okay? Now, let's see if we can make sense of this question. The root of an equation indicates where the graph of the equation crosses the x-axis. A double root occurs when the graph just touches the x-axis but does not cross it. Okay, keep that in mind and look at these three graphs. Which of these graphs would have two unique roots? I need 1, 2, 3. Very good. Down here, we would say that there are two unique roots, meaning two different values of where it crosses the x-axis. Which one has a double root? This first one, because the characteristic of a double root is that the graph comes down and touches the x-axis and then goes right back up. So we say that there is one unique root, or it's a double root. Okay? Now, I want to enforce something real quick here. If we go down here, that's not quite, if we go here, if 0 is a root, what is one of the factors of our quadratic going to be? No, if 0 is the root, what is one of the factors? Isn't x minus 0 one of the factors? If we stop right there, is this quadratic? No. So in order to make it quadratic, don't we have to have the factor of x minus 0 happening twice? And therefore we get the second degree. That's what a double root looks like. Okay? So I want to challenge you guys. If we had a quadratic that did this, and it hit right here at 3, 0, could you write out what this equation would be in factored form? Okay, so if a 0 is at 3, that means one of the factors has to be what? X minus 3. What's the other factor? X minus 3. Because this is a double root, that means there has to be two factors that are exactly the same. You with me? Okay, Caitlin, how could we write this differently?
Y equals x minus 3 squared.
Very good. We can also write it like this. Getting all that? Okay. Let's take a look now. It says use the graphs to identify the solutions to each equation and then solve it using algebra. We're just going to do a couple using the graph. So let's look at question 3a. If we want to solve x squared plus 2 equals 14, which graph are we going to use? Yeah. Do you see that x squared plus 2? We want to know when it equals 14. So what are we going to draw? Yep. I think it's all the way up here. There's the line y equals 14. And we are looking for where that quadratic hits that line. Nico, what do you think the answers are about?
I think the answers are about 3 and negative 3.
Okay, 3 and negative 3, maybe give or take. Okay, so let's go down here, and this is where the skill really comes in. We're going to solve this using algebra. All right, can we just take the square root of both sides? Why not? What's different here? We got to get rid of that plus 2. How do we do that?
You minus it
Good.
and add it to.
Subtract it from both sides. We get to here.
And then you put a
Now what?
another square root. thing.
Now you do the square root of both sides.
Yeah.
And we get x is equal to plus or minus square root of 12. Looking at this chart up here, where does 12 fall in that list? Between 9 and 16, sorry. And the square root of 9 is 3, square root of 16 is 4. So this is going to fall somewhere between 3 and 4. I believe, does anybody have a calculator? I believe it was 3.16, approximately. Okay? All right, how would we solve this one? What? Square root both sides. Is the square root of 10 a perfect square? No, but what's it going to be in between? 3 and 4. Which graph are we going to use to look at it? Yeah, when is x squared equal to 10? So 2, 4, 6, 8, 10. And if you notice, it's falling just slightly bigger than 3. Okay? Okay, we're going to do one more like this. Question C. When is x squared minus 8 equal to negative 5? Zach, what are we going to do on the graph? What? No, I asked you about the graph. How are we going to show on the graph when x squared minus 8 equals negative 5? Gigi?
Use the bottom.
You use what?
The purple one.
Yep, we use this one. And what are we going to draw on this graph? What? A horizontal line at negative 5. And where does it intersect this graph?
2.
Close to 2 and negative 2? Okay. All right, let's solve this using algebra. What would we have to do first here? Jackson?
Add 8 to both sides.
Very good. You have to add 8 to both sides. So you get 3 is equal to x squared. Brooklyn, what's the next step?
You find the square root of both sides.
Very good. So x is equal to plus or minus square root of 3. And we know the square root of 4 is 2, so square root of 3 is slightly less than that.